Zone-based firewall is another implementation of firewall on iOS. This one is basically a syntax wrapper for CBAC, meaning that all the features we have available for context-based access control, they're going to be actually available from within the zone-based firewall configuration. The main advantage over CBAC is that policies can be built in a more structured fashion that ultimately allows us to implement virtually any policy regardless of the number of the security zones. And a security zone is basically a part of our network that requires regulation of inbound or outbound traffic through the policies. So this concept, the concept of the security zone, is extensively used, and the reason for this is that the policies we will configure, they're going to be very flexible and granular because we will be applying them to so-called zone pairings rather than the individual interfaces on a per direction basis. So if we take a look at the context-based access control feature, so the legacy way of implementing the iOS firewall, the configuration of this one is not very granular, especially when we have more than just two interfaces. So the problem with CBAC is that the inspection rule, it is always going to be applied on a physical interface for a particular direction. So for example, we can apply a rule outbound, which on the outside interface, which is going to affect all the packets going from the DMZ and the inside interface. Or if we change the direction here and apply rule on the DMZ in the inbound direction, this is going to affect the traffic going to the outside and also to the inside devices. So there can be only one rule applied per direction on a single physical interface with context-based access control, which leaves us with just a little bit of granularity. We are not able to create separate policies based on the different subnets or maybe sources, individual sources of traffic. This is not possible with CBAC. So with zone-based firewall, what's gonna change is that we will be using so-called zone pairs, which are gonna be those virtual interfaces where we will apply the policies. And this is gonna increase the granularity of the policy up to the individual IP addresses. So for example, with zone-based firewall configuration, we are gonna create multiple zone pairs. One is gonna be for inside to outside packets. The other one is gonna be for outside to inside. We can have a separate policy for DMZ to the outside, for outside to DMZ, and so on and so forth. So these structures, these so-called zone pairs, this is where we will actually apply our policy. So as you can see, the policies can be very granular. We can have a separate policy for inside to outside. We can have another one for outside to inside. And for those individual policies, we are going to be using so-called modular QoS CLI syntax. So we are going to be dealing with the class maps, policy maps. And since one of the matching criteria in a class is going to be an access list, we can create very granular classes even for the individual devices. We can say that we want to inspect the packets coming just from one individual host on the inside, with host number 2 being destination on the outside, and this may make up our first class in the policy, versus we can have another device here on the inside, and for this traffic we are going to create a separate class and apply a separate inspection rule, such as inspection tuned with so-called parameter maps. There are 4 general rules we have to keep in mind when working with zone-based firewall. So this is what's known as the 4 principles. And the first rule says that traffic between interfaces that belong to the same security zone, such as inside, those packets are always going to be allowed. So this is so-called intra-zone communication for the traffic going between the interfaces that are part of the same zone. Now, if the interfaces are part of different zones, which is going to be the inter-zone policy, those packets are dropped by default, and this is something we can change by applying that policy to the zone pair. So for example, inside to outside zone pair, by default the packets are going to be dropped for those, but when you create a policy and enable inspection for some individual classes, the packets are going to be allowed from the inside to outside for the devices we have classified as part of those classes. Okay, the third rule says that for an interface that is assigned to the zone, when it wants to talk to the interface that is unassigned, and vice versa, so for the packets that are sourced from behind the interface that is not part of any zone and are destined to the interface that is part of a zone, no matter what zone, this traffic is always going to be dropped. So there is no way to communicate through the interfaces as long as only one interface is assigned to a security zone. And the last rule says that for the traffic to the router itself and from the router itself, this is what's going to be represented by a zone known as self. This traffic is by default allowed. So all packets destined to the router itself to one of its physical or logical interfaces, which are represented by the zone self, this traffic is going to be allowed by default. And also for the packets sourced off the router, such as routing protocol updates or maybe a telnet session from the router itself, this traffic is also going to be allowed by default. Okay, now for configuration, as I mentioned earlier, we're going to be dealing with modular QoS CLI syntax. So there is going to be a class map defined, which is basically a container for the traffic. We're going to create a policy where for individual classes we are going to specify our action, such as police or drop. And finally, we are going to apply the policy using the service policy command, and the policy is going to go to the individual zone pair, for example, inside to outside. Now, the key thing to remember when working with zone-based firewall is that the class map, the policy map, and the service policy, they're always going to be type of inspect. So when you create the class map and the policy map, you have to say that this individual component, MQC component, is going to be type of inspect. Now for the classification criteria inside of a class map, we can pretty much use two of them. We can use an access list, which is going to allow us to be very granular in terms of what traffic we want to match in the class, or we can use the so-called match protocol command. So the match protocol command, this is something that is going to be using the port application mapping to figure out what packets should be classified to the individual class. And the key difference between the two, so between the access list and the match protocol command, is that the match protocol option, this is to create an optimized configuration of our zone-based firewall policy. So the key thing here is that with an access list, so for example, if we have just one access list entry, permit TCP from anyone to anyone over port 80, and we call this access list from within a class map, this access list is obviously going to be matching packets destined to TCP port 80, which is going to be HTTP packets. But this is not going to be an optimized way of configuring our classes. And the reason for this is that the router internally has no way to say what is going to be the inspection engine I would like to associate with the class that matches that access list. What it essentially means is that for every single packet that will be matched by this class, so this is going to be an HTTP packet, the device is always going to go internally to the PAM table, trying to figure out what should be the inspection engine selected and applied for the packets matching this class. And I am obviously talking about the inspect action, when the inspect action is enabled for the class in the policy. So even that we know that this access list can only match HTTP packets, the device internally does not know that, and it will be checking the PAM table for every single packet matching this class. And this is as opposed to the match protocol command, which in addition to matching packets also explicitly selects the inspection engine with the configuration such as match protocol HTTP in the class. So with this command enabled under the class, the class map is obviously gonna match all TCP packets sent to port 80. So this initial step is gonna be exactly the same as with the access list. But for the second step, for the selection of inspection engine, the device will automatically know that once the packet matches a class with match protocol HTTP command issued, the packet should be automatically inspected as HTTP. So it will not be going to the PAM table for every individual packet trying to select the inspection engine. The match protocol command automatically selects the inspection engine once you issue the command in the class and apply the policy. Okay, from the operational standpoint and the inspection standpoint, there is going to be virtually no difference between using an access list and the match protocol command. If the packet is a FTP packet, no matter we have matched it using an access list or the match protocol FTP command, once the entry is found in the PAM table, the packet is going to be inspected as FTP, meaning that things such as secondary channels will be automatically opened. But whenever we use the match protocol command, so match protocol FTP, match protocol HTTP, this is basically an optimized way of configuring zone-based firewall, which allows you to save some of the resources on the device. So once we have created the different classes, the next step is going to be to create a policy. And for those individual classes, we will have to specify an action we would like to take for the packets. So we can either configure rate limiting, which is going to be the police command. We can simply drop the packets. We can, as I mentioned earlier, enable inspection for the packets. Or we can say that we want to pass the packets, but in only one direction without inspecting them. So the difference between the pass action and the inspect action is that the inspect keyword, it enables true stateful firewall for all packets matching the class, meaning that there is going to be an entry added into the connection table and return packets are going to be allowed based on that entry, as opposed to the pass command, which is creating one-way exceptions to the policy. So for inter-zone communication, as I mentioned earlier, the default action is to drop the packets. If you use pass action, you're going to simply allow the packets in one direction, but no state entries are going to be added to the connection table, meaning that if you don't have pass action defined for the other direction of the flow, the return packets are going to be dropped by the firewall. And the last option we can enable in the policy is the URL filter keyword, which is, as you can imagine, to enable URL filtering using the zone-based firewall feature. Okay, so once we have defined the classes and the policy, the next logical step is going to be to create the security zones using the zone security command. Then we are going to create the zone pairs. So there's going to be a difference between the inside-outside and outside-to-inside directions. As long as you want to create the policies for both directions, you would have to apply them to the both zone pairs. So one inside to the outside. This is going to be one policy, and the other policy for outside to inside. And the way we apply the policies to the zone pairs, this is by using the service policy type inspect command. And the last step is going to be to associate the physical interfaces, or maybe also the logical interfaces, such as virtual templates, with a particular security zone, and this is going to be the purpose of the zone member security command. Okay, for the other things we have to remember about when working with zone-based firewall is that our classes, they are going to be, by default, all the classes are going to be type of match all, which means that all individual criteria in the class must match for a packet to be classified as part of this class. We can change this matching logic to be the logical OR operation. This will be the match any keyword. And then as long as one matching criteria is met for the class, the packet is considered to be a match for the class. And the other thing is that the order of classes inside of a single policy map is gonna be important. Well, actually, for the class maps themselves, when you use the match any option, so the logical mathematical OR operation, the order of statements in the class is also gonna be important. So let's take a look at a following example. Let's say that we have a single class map, and this is going to be type inspect because we are dealing with zone-based firewall. The matching logic is going to be match any, and the class name is going to be ex1. And here what I'm going to say is that we will use the match protocol command as the classification criteria. Match protocol TCP, and then the other one is going to be match protocol HTTP. So with a class map defined in that way, what's going to happen is that every single HTTP packet is going to match this entry because it is higher in the class map here. So actually what's going to happen is that all HTTP packets, since they match the match protocol TCP command, they are going to be inspected as TCP. Of course, assuming that the inspect action is configured further for this class in the policy. So we definitely want to put the more specific protocols higher in the list here, meaning that match protocol HTTP would be first in this list here. And only then when there is an HTTP packet going through the device, it would match that match protocol HTTP statement, and the packet will be then inspected as HTTP rather than TCP. So once again, the order of the match statements for match any classes is also important. So this is the first thing we should remember about. And the other one is, as I mentioned, for a single policy map, type is going to be inspect POL1. The order of classes in the policy is going to be important. So assuming that we want to use the same example here, class TCP inspect, then class HTTP inspect, assuming that class TCP matches TCP packets, all TCP packets, versus class HTTP matches all HTTP packets, then every single HTTP packet going through the matching this policy is going to actually end up in this individual class TCP, just based on the fact that there is an overlap between HTTP packets and TCP as the protocol. So all HTTP packets, they are actually TCP packets sent to port 80. And since class TCP is higher in the policy, those packets are going to match that class and will be never inspected as HTTP here. So we would basically have to do the same as in our previous example. We would have to make sure that more specific class maps are higher in the policy. And this is obviously only for the classes that overlap. If this first class was TCP, but instead of, let's say, this one, let's say we would be matching UDP packets, there's definitely no overlap between TCP and UDP. So we could basically leave them defined as they are now, or we could say that the first class would be for UDP, the other one would be for TCP. It doesn't really matter. The order of classes in the policy only matters when there's an overlap between the classes. Alright, now when we have gone through the basic layer 3-4 zone-based firewall configuration, we can quickly discuss application level class and policy map. So this component, the layer 7 zone-based firewall, this is something optional. And the main advantage of creating those level 7 class and policy maps is that we can tune the behavior of the inspection engine at layer 7 And in addition to that, we can also extend our matching criteria to be those available at the application layer that are specific to individual protocols, rather than those generic information such as IP addresses and port numbers at layer 3, 4. So for example, we can say that for HTTP packets, we only want to look at packets that are sent to a particular URI or maybe a host field, which information would be found inside of the HTTP header. Or maybe for simple mail transfer protocol packets, we only want to match those that do not conform to the RFC. And the configuration for layer 7 zone-based firewall is going to be actually very similar to what we saw for layer 3-4 generic configuration. So there is going to be a class map that must be defined that is going to define our matching criteria. Type inspect is going to be the same as for layer 3-4, but now the difference is that we are also going to specify the protocol name, such as class map type inspect HTTP. So this is what's going to make this class map a level 7 class map. And then for the policy, we are going to do the same. So this is going to be policy map type inspect and the protocol name. So this is what's going to make the policy a level 7 policy. And finally, inside of this level 7 policy, we are going to call out our classes, specify an action, such as drop the packets, and finally the policy map, this level 7 policy map. This one is going to go to the layer 3-4 policy that is applied to the zone pair. And a key thing to remember here is that this layer 3-4 policy, the class where we will nest our policy, this one must use the match protocol command for classification. So for example, if you take a look at this on the whiteboard, there's going to be a level 7 class map. Class map type is going to be inspect, and the protocol is going to be, for example, HTTP. This is where we will define our level 7 matching options. Then we are going to create a policy map, which is going to be also type inspect, and the protocol is going to be HTTP. We are going to nest this class in this policy, so we are going to say class, for example, level 7. We are going to specify an action, such as drop. And this policy, the level 7 policy, this one is going to be nested in layer 3-4 policy map for an individual class. So we still have to define a class, level 3, level 4 class, which is going to be class map type inspect. This time you don't specify the protocol name. Let's call it L4. Here we will have to match the protocol we would like to tune using our level 7 configuration. So match protocol in this case must be HTTP. So this protocol must match the protocol we have configured for the class and policy map at layer 7. We could also add another entry here for an access list just to narrow down the scope of the class. But the main requirement is that the match protocol command must be issued, so we have to explicitly select the inspection engine. Then for the policy map, type inspect for this particular class. Let's call it POL. For this particular class, so L4, we want to say that we want to enable inspection. And in addition to that, we also want to nest our level 7 policy for this class here. And this nesting, we are going to configure it using the service policy command. So if you take a look at those commands from the configuration standpoint, we're going to start with trying to logically approach this configuration. We're going to start with the level 7 class and policy map. Then we're going to build our level 3-4 class and policy. And finally, the level 7 policy is going to be nested under this level 3-4 policy, which actually goes to the zone pair. Okay, one more thing that is related to zone-based firewall configuration is a parameter map structure, which is basically a set of configurable parameters used by the firewall inspection engine, by the main inspection engine of the zone-based firewall, and also by the URL filtering feature of zone-based firewall. So the firewall inspection engine, this is gonna be for the settings we saw with CBAC, the timeout values, the denial of service thresholds, enabling features such as alerts or audit trails, maybe setting up the maximum number of sessions a firewall should handle for a particular class, as opposed to the URL filtering, where there are going to be two different types of the parameter maps. The URLF policy, this is where we will define the address of the filtering appliance, whereas the URLF-glob parameter map would be to define static exceptions to the policy, such as the domain names or individual addresses of websites we would like to create a static policy for. We wouldn't like to consult the filtering appliance when sending packets to those URLs. So this would be an equivalent of the CBAC's IP URL filter exclusive domain command. But in the vast majority of cases, we are going to be dealing with a parameter map type inspect, which is once again used by the firewall, the inspection engine in general. And one thing you should remember about this one is that for all of the settings you do not specify in a parameter map, you will then apply to the inspection rule. They are going to be inherited from so-called default parameter map. So we can say show parameter map type inspect default, and it is going to show you those different configuration options you have within a parameter map and their default values. So whatever you do not set using your customized parameter map is going to be inherited from the default parameter map that is pre-configured on the device. Okay, for IP version 6 support for zone-based firewall, this feature is available and the configuration is going to be exactly the same as in IP version 4. Just remember, there is a separate port application mapping table. For configuration, this is going to be the IPv6 access list, not IP version 4. And in terms of the default settings, there is one you should be definitely aware of, namely the routing extension header packets. All IPv6 packets with the routing extension header set, they're going to be dropped by default by the firewall. So if you want to start inspecting those packets instead of dropping them, you need to change one of the settings inside of a parameter map type inspect, which is going to be enabling the IPv6 routing header enforcement command. So then you would apply a parameter map to the inspection rule, and this would force the device to start inspecting packets with routing extension headers. And for the remaining configuration, the logic is going to be exactly the same. So we will have to create the classes, the policy, the zones, zone pairs, apply the policy to the zone pair, and finally associate the interfaces with those different zones we have defined. An example configuration, actually part of it for zone-based firewall. One thing I wanted to show you here is how to associate a parameter map with the inspection rule. So I call this one tuned because I have modified one of the settings. I have enabled other trails for this parameter map. And the way you apply it is going to be under the level 3 for policy. For an individual class you want to enable inspection for, you basically call out the parameter map as a configuration option to the inspect command. And once again, remember that for all other options we did not define in our parameter map, such as the alerts, the thresholds for denial of service, the timeouts, they are going to be inherited from the default parameter map that is pre-built, pre-configured on the device.